ప్రెసిడెంట్. హలో హలో, గుడ్ ఈవినింగ్. ఏంటి?
సార్ గుడ్ ఈవినింగ్ సార్, సీతారాం బాబు గారు, సార్ సత్యనారాయణ సార్ గారు.
ఓకే. హలో సార్, హలో చైర్మన్ సార్.
గుడ్ ఈవినింగ్
రామలింగేశ్వరరావు గారు.
సార్ గుడ్ ఈవినింగ్ సార్, రామలింగేశ్వరరావు గారు. గుడ్ ఈవినింగ్ సార్.
గుడ్ ఈవినింగ్ సార్.
గుడ్ ఈవినింగ్ చైర్మన్ గారు.
గుడ్ ఈవినింగ్ సార్.
సార్ గుడ్ ఈవినింగ్ సార్.
గుడ్ ఈవినింగ్ ఆల్ ఆఫ్ యూ సార్. కొండయ్య.
గుడ్ ఈవినింగ్ సార్. రాజుగారు వచ్చారు. గుడ్ ఈవినింగ్ సార్, రాజుగారు.
గుడ్ ఈవినింగ్. మీ గ్రూప్ జాయిన్ అవ్వరా? మీ ఫ్రెండ్స్ గ్రూప్ ఉంది కదా, వాళ్ళు కూడా జాయిన్ అవ్వనండి.
జాయిన్ అవ్వమని ఇచ్చాను, మెసేజ్ పెట్టాను. నాకు ఎంతమంది వస్తారో తెలియదు.
అంటే వాళ్ళ పండగ సార్ ఎట్లుంటుందో.
ఈరోజు చాలా మంది, అందరికి హాలిడే అనుకుంటా సార్, అన్ని ఆఫీసులో కూడా.
ఆఫీస్ ఎలా వచ్చింది కదా అతను.
రామలింగేశ్వరరావు గారు,
నమస్కారం సార్. నమస్కారం సార్.
ఇది యూట్యూబ్ లో స్ట్రీమింగ్ అవుతుంది, తర్వాత చూడవచ్చు మన వాళ్ళు ఎవరైనా.
ఏమండి?
యూట్యూబ్ లో స్ట్రీమింగ్ అవుతుంది.
యూట్యూబ్ లో అవుతుందా?
మనం ఎప్పుడైనా ఇప్పుడు మీ వాళ్ళు ఎవరైనా ఇక్కడ ఎప్పుడైనా చూడవచ్చు.
అలాగండి, అలాగే.
ఇంకో 5 minutes వెయిట్ చేద్దాం సార్.
అలాగండి. ఏంటి?
రాకపోవచ్చు సార్.
నేనే చదువుతా ప్రొఫైల్.
సార్ రమ జాయిన్ కాలేదు కదా? సార్ సీతారాం బాబు సార్,
సార్
మనం స్టార్ట్ చేద్దాం సార్. ఇంకా వచ్చిన
అది వెళ్ళి
వాళ్ళు-
గార్లాండ్ కూడా చేసి రావాలి కదా 10 నిమిషాలు పడుతుంది
అవును.
మనకి ఎట్లయినా.
అవును అవును అందుకే సార్ స్టార్ట్ చేయండి సార్.
సార్ గుడ్ ఈవినింగ్ టు వన్ అండ్ ఆల్ హియర్. ఐ thank Dr. B. Ramlingeshwar Rao Garu, former Chief Scientist Engineer Hyderabad, has kindly consented to be the chief guest, agreed, and as now to the keynote speaker for the today's event on Engineer R.L. Raju Gari 10th Endowment Lecture. The topic would be on new seismic zoning map of India with reference to dams and irrigation projects. I invite the chairman of the Institute of Engineers, Dr. G. Venkat Subbiah Garu, and the past chairman and the council member, Dr. A.S.M. Raju Garu, Nagesh Garu, Venkatramana Garu, and Konde Garu to this event. Sir, before we get into the formalities of the event, myself and Raju Garu would go and offer flowers and garland a portrait of A.L. Raju Garu. That will be shown in the Zoom, sir. Please await for 10 minutes, sir. We'll be back. Thank you.
సార్ రత్నం గారిని అక్కడ వీడియో పెట్టమని చెప్పండి సార్.
సార్ పెట్టాను సార్, వస్తుంది నా దాంట్లో.
రైట్ రైట్, ఇప్పుడు వస్తుంది, మాకు ఇప్పటి వరకు రాలేదు.
Now I request the chairman of Institute of Engineers, Dr. G. Venkat Subbiah garu, to preside over the R.L. Raju gaరి 10th endowment lecture, sir, please.
థ్యాంక్ యూ సార్. డాక్టర్ కె సీతారాంబాబు గారు. రెస్పెక్టెడ్ keynote స్పీకర్ డాక్టర్ బి రామలింగేశ్వరరావు గారు, ఫార్మర్ చీఫ్ సెక్రటరీ సైంటిస్ట్, NGRI హైదరాబాద్. డాక్టర్ కె సీతారాంబాబు, FIE హానరీ సెక్రటరీ, IA తెలంగాణ స్టేట్ సెంటర్. డాక్టర్ ISN రాజు, కౌన్సిల్ మెంబర్, IEI తెలంగాణ స్టేట్ సెంటర్. ఇంజనీర్ జి నరేష్ గారు, ఇంజనీర్ కొండయ్య గారు, పి వెంకటరత్నం గారు, వెంకటరమణ గారు, past chairman, honorary secretaries, corporate members, committee members of IEI, if any are present today. Ladies and gentlemen, good evening to all of you. Today I feel it is a great privilege and honor to be amidst this August gathering and extend a warm and hearty welcome to the keynote speaker and all of you to Engineer R.L. Raju 10th Endowment Lecture. Today, I am very happy to be associated with this memorable event. I am glad to inform that the Telangana State Center of the Institution of Engineers India has been regularly organizing endowment lectures every year on the birthdays in honor of eminent engineers like Engineer V. Subbarao, Engineer M. Tirupati Reddy, Professor K. Gopichand, Dr. J. Purushottam, Engineer G. Prabhakar, Engineer Koka Krishnamohan Rao, Engineer G.V. Subbarao, Engineer T. Hanumantarao, Engineer A.P. Ranganatha Swami, Dr. S. Raghavachari, Dr. Narla Tatarao, Engineer Matur Gopal Rao, Engineer Gurram Kotireddy, Engineer Atluri Venkateswar Rao, Engineer R.L. Raju. Today, we are going to organize this lecture. Dr. Jan A. Murray, Dr. N.V. R.L.N. Rao, Engineers L. Venkatakrishna Iyer, K.V. Srinivasa Rao, and M.L. Swami, Dr. A. Ramakrishna, and Engineer I. Baswaraju, endowment lectures. I take this opportunity to say a few words about veteran late Engineer R.L. Raju garu. Engineer R.L. Raju obtained BE in Civil Engineering from Gindi Engineering College from Madras University in the year 1947. After completion of engineering, he joined the same college and continued till December 1949. After his joining as assistant engineer in the irrigation department, Government of Madras in the year 1956, he was elevated to the post of executive engineer posted in the Nagarjuna Sagar project to investigate and execute Nagarjuna Sagar Right Canal. In the year 1960, he was posted as Deputy Chief Engineer for Nagarjuna Sagar Right Canal, and in the year 1964, he was promoted and posted as Superintending Engineer, Godavari Valley Circle, to execute Pochampadu project, now named as Sriram Sagar project. After serving various positions, he was shifted to Godavari Barrage Design Circle in Chief Engineer's office at Erramanjil. After that, he moved from Godavari Barrage Circle to Vijayawada Irrigation Circle for a short time, and he was promoted as Chief Engineer in April 1974 and posted as Chief Engineer Srisailam Hydroelectric Project, and finally he retired in July 1978 from the Irrigation Department. Engineer R.L. Raju passed away on 4th May 2017. Since you are anxiously waiting to hear the talk from our eminent speaker, Dr. Engineer B. Ramalingeswara garu, I am limiting myself and hope that you will really enjoy this topic. On behalf of the Telangana State Center of IEI and on my own behalf, I once again extend a hearty and warm welcome to keynote speaker Dr. B. Ramalingeswara Rao, former Chief Scientist, NGRI Hyderabad, and all of you for this important event. Thank you, one and all. Now I request Dr. K. Sitaram Babu garu, Honorary Secretary, to introduce our keynote speaker, Dr. B. Ramalingeswara garu.
Thank you very much, Chairman Sir. Dr. B. Ramalingeshwara garu, born on 4th July 1950. He did his graduation in Amal College and post-graduation Geophysics from Andhra University, Visakhapatnam in the year 1974, and later did his PhD on earthquake risk in 1980 from the same university. He worked in various capacities as from 1983 onwards till 2010 in NGRI, National Geophysical Research Institute. Raugar's major scientific contribution 4 decades in the field of seismic hazards of India, continental region, and earthquake physical processes, etc. A few contributions are first discovery on a new seismic zone in low to high grade transition zone, covering the Andhra Pradesh, Karnataka, and Tamil Nadu states. He prepared his first version of stress map of India by using earthquake focal mechanisms. He is the first to estimate pore fluid diffusion rates and causative factor for occurrences of continuous earthquakes in Koina-Varna region. He proposed a hypothesis on major earthquake occurrences in Himalayas, where its M is greater than 7.7 for about 22 years. Rao garu has prepared a new catalogue of Indian earthquakes as a monogram from the earliest to 1200 AD to recent. He is a member in BIS MAPS, that's a body. These dreams make India infrastructure earthquake resistant. Some of the important achievements in scientific and social activities recommended the renovation of Buckingham Canal to Central Water Commission. Earthquake design confidence for new city of Cyberabad and Amravati, given by Dr. Buddha Ramalingeshwara Rao in the years 1999 and 2015 respectively. One of the committee members for construction of nuclear power plant in Jaitapur, Gujarat, along with Professor U.R. Rao garu, suggested vulture strike method, rejected proposal of underground construction of tunnel in Kasu Brahmanand Reddy Park, Telangana government, and suggested elevated bridge to protect ecology and groundwater. Suggested to the government of Telangana to reinstate GO 111 to protect ecology, groundwater, and temperature effect. He also involved in helping poor people for the studies and given guidance to more than 50 young computer science students for mini projects as part of his social activities. Advised seismic coefficient to 1985, Cyberabad, Amravati, and Ayodhya Sri Ramayavar temple. With this profile, sir, thank you very much for giving me the opportunity. I'll get this back to the chairman for his continuance of the event. Thank you.
Thank you. Thank you very much, sir. So now I request our keynote speaker, Dr. B. Ramalingeshwara Garu, to present his talk. Sir, Ramalingeshwara, sir.
Thank you, sir. Good
Thank you,
evening
sir.
to all of the Institute of Engineers members throughout India. Thank you for your invitation on the occasion of the R.L. Rao's Raju Garu Memorial Endowment lecture. It is a great privilege for me from this Institute of Engineers, Hyderabad. I am very glad to explain how Indian continent is experiencing a lot of earthquakes which occurred in the last 1 century. So in my lecture, I want to give, I had prepared a new seismic zoning map of India based on the earthquake data collected from various medieval time to present day. All the earthquakes of 55,000 earthquake data and intensity data covered from the archives of the different literature in the Telugu and Sanskrit and other different languages. We have collected all the data with a view to prepare a new seismic zoning map of India. We need that because in olden days, 6 floors they have constructed. Now, the time has come, the population increased, the need of the housing accommodation is highly essential for the people of India to have a multi-stored building, like skyscrapers for 50 floors and 60 floors. Then we need very stimulus, very important parameters about the seismic activities and their hazards is essential to mitigate the earthquakes. If those big earthquake occur, the structures should not be disturbed. So with that view, I have prepared a seismic zoning with the help of the DST. They have funded me to write a book on historical earthquakes of Indian regions, and they published a book on the seismic activity Indian scenario. From this book, I have taken some of the points, some of the slides, and I'm presenting to you. This is my book for the people for to know this book. This is the only document published by me in with the help of the DST. I have compared everything, data sets, different region, tectonic, seismotectonic activity in the other regions, and prepared finally the seismic. I prepared ultimate use of this database. I prepared a new seismic zoning map of India based on intensity data as well as the probabilistic hazard analysis for the Indian regions. I want to show you each and every part of the Indian regions, the need of the how to make use for implementing the earthquake resistant structures of dams and other small projects or the heavy civil structures. How to make use this type of maps is my present talk. I will consider these parameters, identified how the seismic activity is more and medium and higher level seismicity zones within India. For example, Himalayas are having high seismic zones where we already experienced about 8 magnitude earthquakes all along the seismic in the Himalayan region. And another important thing, I want to explain the usage of new seismic zoning map of India based on the intensity as well as the seismic hazard regions, and explain the seismotectonics and geotechnical investigation. And I'll explain seismic zones and design characteristic zones. I will explain also define response spectrum and factors that affect the shape of the spectrum based on the soil content of the region. With the response spectrum also will change the shape. So that also will explain. I will describe 3-point spectrum construction for the site-specific region. I have prepared some of the maps, and from that map we can construct a spectrum for the any region you want. We can make from the 3 maps. Usage of spectrum generated for this site-specific region, and some other examples also I will explain. Thank you. Next. See, lower and upper seismic hazards. Hazard previously we have been calling earthquake risk. The earthquake risk is nothing but the vulnerability of due to earthquakes, value of the area damage, and hazard. Now they made this vulnerability is equal to 1 and value is 1. So risk is the automatically becomes a hazards. So hazard, the dangerous danger of that area will be known from these analysis. See, based on the probabilistic methodology. The probability of accidents here is nothing but the probability that exceeds certain value of the expected region, and P is equal to time by return period. Time 50 years design. The structure will be, for example, in a building, exposed for 50 years, and how many years a big earthquake will occur that during that segment of the time, maybe 450 years or 2,500 years or 1,000 years. The structure may experience a big earthquake. So what is the probability of hazard due to that big earthquake nearby area? So like that, for example, 50 years design period or 470 years return period, if it is there, the probability is 10%. For dams, bridges, ropeways, metro lines, all these things, we will compute the 475 years. That means approximately 500 years. And another important is 50 years design period for 2,455 years. 50 years, that means almost 2,500. His probability is 2%. Actually, the civil engineers will consider for the scribe capacity, 6 floors or any other region, hospitals, schools and sky cappers, towers and others. They will consider this type of probabilistic method. Another one is normal buildings frequent earthquakes may create cracks and partial damage, which may not, for 100 years, the small normal things will, we can retrofit it. For monumental structures like very big temples like Tanjavur, Kodeswara or something like Kanchipuram, some places you see monumental stairs and towers, they can survive up to a return period of 1,000 years. You see, we have, because you are in civil engineers, from the angle of seismological view, we have to inform to this the civil engineers for the hazard, how hazard timings and how the groundwork, because of the ground disturbance, accelerations due to earthquake is creating damage to the structures. For different periods, for example, 100 years, the ground shaking will be less for this region. we can retrofit that structure. For example, 500 years, that means 475 and 10% probability. That is for dams, irrigation projects, or some other things we will consider that probabilistic value of that written period. So for normal structures like skyscrapers and other civil structures, we need to know 2,500 years. That means 2,450 years. USGS have considered these two parameters, 400, 500 and 2,500. And ASTO had given 1,000 years, like that. See, the distribution of the earthquakes. Previously, the people have considered only Himalayan earthquakes because of the subduction of the Indian plate into the Eurasian plate, made the big earthquakes the slip potential is more because of the subduction of the Indian plate under the Eurasian plate, created a large number of earthquakes as well as very big earthquakes, very frequent 7.7 earthquake may occur about 22 years period. I have already mentioned in my publication. So like that, and Indo-Gangetic plates is a mediocre, and actually South India, Peninsular India, considered to be the stablest land. After 1967 earthquake of Koina, the concept of the stable region has changed because of the observation of the earthquakes have been increasing day by day because of the loading effect of the structure or the number of faults structures. We can understand that we should take care about the hazard of the every part of the region and by using the data set. You see, because of the faults, active faults, inactive faults, or deep faults, and shallow faults, that was marked by the Geological Survey of India. They published it as a atlas of seismotectonics in 2000. They have shown that actually any building or any dams or irrigation projects, the faults are mainly to be considered very seriously, whether the fault zone is there or not. Otherwise, we will be, our design of the dams or irrigation projects will be affected much because of hydrostatic pressure load on the fault may displace something. So we should be very careful about the engineering geology of the area and consider for the dams and other things in a big project like Polavaram and other things we have to consider. Kaleshwaram project and other things we have to consider seriously about the geological engineering aspects also very seriously, as well as the seismicity of the region. Actually, our Indian peninsula and the Indian continent is comprises of the three cratonic regions, comprises of three cratonic regions. A craton is a strength material with high strength material, stable region, and it will not be create any disturbance. That's why people thought that this is most peninsular India is more stable. But here in peninsular India, we got Bastar Craton, Bandara Craton known as, and another is this is Bundelkhand Craton, and Dharwar Craton is near Bangalore and above Karnataka region. This is Dharwar Craton. The Dharwar Craton was broken long back and creating large number of earthquakes, and now seismic activity is shown. The small circle in the near Bangalore, below Bangalore, is a nucleus of that crater is known. So in Bandara Craton and again nowadays this Bundelkhand Craton is also being showing some activity, seismic activity. So number of any region, you should consider also the seismic activity of the region and very carefully, and then design these structures for dams or any irrigation projects. As a observation made by the Bilham and Wallace in 2001 and 2005, they found that we know that large number of earthquakes, big earthquakes occurred for last 50 years. Say, for example, 1905, 8 and Mandya earthquake, Nepal, Bihar earthquake, and Assam earthquake, and some other regions, very big 8 magnitude and above earthquakes have slipped down the Indian plate into the Eurasian plate. How the slip, the red mark is indicating the slippage of the 4 meters or above. If 4 meters displacement of the crust inside the Eurasian plate creates 8 magnitude. Beyond that value is giving 10 meters. For example, Indian Ocean tsunami, you know that in Jakarta region, Indonesia, the 10 meters displacement of the oceanic crust inside the continent. That's why you got 9.3 magnitude of earthquake. So as the displacement of the crust is going inside the continent, with about 10 meters, is giving indicating 9.3 magnitude earthquake. The size of the earthquake will be more dangerous and more powerful. That's why 2.5 lakh people died because of the Indonesian earthquake. So we computed how many earthquakes, how much of the slip has taken place all along the Himalayan arc region. About in the right side figure, yellowish block is showing what is this slippage, what will be the expected 8 magnitude in Himalayan zones for Nepal, Bihar, and some other region, northeast region, northwest region. See here, in my PhD in 1979, I did with the available data set for and prepared a seismic risk map of India for 50 years design period as well as 30 years. I have shown now the 30 years design period how the even today, after a collection of the intensities and other data, modern data set also is showing the same values. That means the accuracy of the calculations of the earthquake is even today is valid. That's why it is showing the same thing in my map. In the next maps also I will show you. See, maximum observed intensity. Any earthquake occurred, the damage of the structures will be observed on the field sites. All the geologists who, after the occurrence of the earthquake, geologists will go and identify the damages occurred due to that earthquake. They have recorded and they explained every damage capacity, and they have given MSK value for that earthquake location, and they have given number of isoseismals also. Based on the number of earthquake intensities, I prepared this intensity map of maximum intensities of the region and plotted as shown. It is showing some, because of the different soil structures above the ground level, that means basement, the damages will be different from one side to another side. That means we need to have a seismic zoning map of India based on these data set, and give an indication to the designers of the structures, for example, dams or any irrigation projects or multi-floor storage buildings. They have to have one parameter. That parameter we have to prepare. See, based on 56 isoseismal maps prepared by different geologists and geoseismologists in India, I digitized all the data set and made the preliminary seismic zoning map of India to give some intensity, what is the zone factors. Previously, several people have worked on the in zoning map of India based with tentative observed 10 or 15 isoseismal maps and prepared. Now the data has been acquired by me, several isoseismals and data sets, and based on that, I have prepared the map based on the geostatic software by using the software and found that number of damages, more is damage, more the magnitude we have given as and accelerations are more. When there is a acceleration is more, the damage is more. So based on that, we have given assigned a zone factor. This zone factor is identified and given different regions, different zone factors, and their zone values also in my map. This is a preliminary map I made it, and afterwards refining the data set, I made another map. Professor Jaykrishna in 1959 had prepared a preliminary zoning map by using empirical equations of accelerations is equal to magnitude and the focal length and everything and the epicentral distance. Based on that, he found that three zones, a very, very damaging zone, that is more than 30%, that means 0.4, 3.6 or something G. Peak ground acceleration is more about that. And another zone is heavy damage in the Himalayas. That is heavy damage is 30%, 0.3 G. Peak ground acceleration is 0.3. For any dams, if you construct or any irrigation project you do on the Himalayan regions or for the purpose of power supply or something, Tehri Dam, I have given in 1985 design coefficient for the Tehri Dam construction. The committee, one of the committee members in that, and we have given 0.34 value at that time. And like this, based on the actuaries map of India prepared by me. Another layer is 10%. So if you will go to the Indo-Gangetic plains, light damage. Previously, the identified Peninsular as a stable continental regions, label paid. That means no earthquake later. It was being identified to be considered with the smaller earthquakes also, frequent earthquakes also occurring in Peninsular India. We need to study that. So based on this, how to prepare the seismic zoning map of India, there must be some procedure has to be developed with the observed earthquake data, and we prepare a acceleration relationship between the moment magnitude, intensity, and zone factors, and zone factor as well as the peak ground accelerations for different intensities or the different magnitudes. We can have right side one zone factor division has been done by me. With this graph, we have identified, and with if this value is falling within the range of that, we identified zone 1, 0.1 to 0.1 up to 0.1, zone 2, 0.16, 0.11 to 0.16, that is zone 3, like that 0.161 to 0.24, zone 4, like that we have divided the whole region, and above that 0.36 above we will get zone 5. So for that, based on these parameters, we can assign some design coefficients to the structures in the calculations of the any structure like skyscrapers or dams or anything else. I will show how to take that. This is the map, right side, left side map is prepared by me based on the intensity data as well as the seismic hazard zonings of the region for whole India. And this is the raw right side map is a rough map prepared by the Bureau of Indian Standards based on my data also, and they have considered some of the parameters and some of the boundaries of that area also, and they identified the different zones, but I have given 2, 3, 4, and 5. They have given 2, 3, 4, 5, and 6 also there. In this later, maybe it will be released after some time. This is the Indian seismic zoning map of India. Is a present scenario. This is a draft copy. Next. See, see, for example, design earthquake zone factor, they have given for different seismic zones. And see, for example, for 475 years, for zone 2 and zone 6, 5, sorry, 6, they have given 0 and third column. And for 2475 years, the another higher value they have been observing. So because of that higher value, we have to be reconsidered. And beyond that, we can more and more the value of the peak ground acceleration taken for the 2% probability. We have to invest more money and actual value more than the actual value they have given because of some reasons. The retrofitting is not necessary, they are telling. But actually, we have given based on the earthquake data. The whole India, they have considered B2C soils, but we have not considered the B2C soil because every region, every place is being changed from one point to another point. B, C, D also is there. So we have to take the local geotechnical investigations. Nowadays, so number of techniques have evolved here for accuracy of the area. Macrozonations can be done for any city development. For example, Amravati or any other city, newly constructed cities, we have to consider. This is see the actual elastic. The curve itself is showing it by considering the data set. They have we automatically in the left side axis we got where is the actual values of the observed accelerations as well as the time period they have given in zone wise. Zone 3, zone 4, zone 5 they have given. It is given by Subramanian Velayat in 2012. See how to develop, how to create a spectrum for the any region. For example, if you take number of height of the building, first floor, second floor, 10 floors. So if you install accelerometers on that, you will get different seismic acceleration graphs like this. The more is the amplitude, high is the peak of the spectrum will be there. The spectrum can be generated by using the earthquake occurrence and the recorded accelerations. We can develop a spectrum for that area by calculation. This is a different earthquakes will have different frequencies. This is in the right side, one via sorry, y-axis, we got the amplification parameter, amplification zone. So like that for different earthquakes, we'll have different frequencies. We'll have a structural experience. For the same ground, we can have different ranges of structural experiences. See, based on this basic idea, the any region which is experiencing a number of earthquakes at the site where we are interested, we can identify calculate the zero period acceleration at zero level, at zero period. Well, how much is the maximum amplitude of this peak ground acceleration has been observed during the last occurred earthquakes data. In the present, we have taken, based on the Professor Iyengar data set, he had prepared probabilities of the different regions. So I have taken 2,450 years and design period is 50 years and 2% probability of accident. No, this is for ZPA, zero period acceleration. Another one is one period. 0.2 seconds, another map we have prepared, and this is for 1 second. That means we have shown in the first spectrum calculation, different period, different maps for the whole country. You can prepare any spectrum for any region you are interested. For example, I'm interested in Bhopal. For example, Bhopal region, we will identify the lat longs and we will take the data from the map. From the map, we can identify the values and prepare a spectrum like this. If for any region, we can prepare a spectral acceleration graph, and from that, what period it will be, the structure will resistant to this value. So we can understand from the spectral accelerations. Previously, what they did, they have identified hypothetical three curves put in one in BA's law previously, but it is not the case now. Because of the calculations of different regions, different parameters, three parameters we can generate spectral accelerations of any region and identify the frequency of that. The period is natural period of the building and natural period of the ground should not be equal. Otherwise, if they are equal, the structure will be collapsed. So what is this actually the spectrum, what it reflects and what is the shape of the structure will be known. Because of this is a rock, below that is a ground rock area, and that soil content will be there. Some places, so 30 meters soil will be there. From there, we can, on that we can construct any structure, for example, 3 floors, 5 floors, or 10 floors. Nowadays in Hyderabad, 50 floors they are constructing. In Calcutta, Marsi area, they have constructed 42 floors. See, according to their wish, they are doing, it is a very danger. After any earthquake occurrence, these buildings will be collapsed because they have not considered the earthquake frequency of the area and structure of the soil as well as the rock and fault zone, and your structure will be damaged or totally collapsed. So based on this concept, if you are in the soil, if you are in the rock, your structure is on the rock, the lower part of the structure will be like this. If you are in the soil, if you construct a structure on this soil region, the ground acceleration will be more, and the spectrum also higher. That means the application has been taken place. Hazard is more or less, we have to identify from the any region. See, this is the a basic concept. Actually, actual earthquakes will occur with the spectral acceleration. If you do, the actual waveforms will be showing some actual spectra in the upper part of the curve is showing the actual observed value at that side. That if you remove the soil and find an acceleration, you will get another yellow line, yellow spectrum. If you are designed for these based on the observed actual and the ground spectral basement structural value, you can design any structure for for example, the nature of the structure, for example, dams or irrigation projects or multi-story building, anything you have to design. Anything should be designed, otherwise the earthquake may create damage fully or partially in the interested area. See, for example, this is my observations I made from these maps. Above maps, 3 maps I have given and prepared the acceleration graphs for different D type of soil. This is Tillur region in Amravati area. And another is second is Hussain Sagar, near Hussain Sagar in Hyderabad. They want to construct 100 floors in nearby that area. What is that soil content? They have not considered, but they want to construct 100 floors. So I want to express that is it danger or non-dangerous, or you have to consider the actual values of the spectrum. At what period this will be maximum peak ground acceleration will occur, because based on this spectral acceleration we can identify and indicate the design quotient should be more or less, we have to consider. Even for Ayodhya I did, and Ongole we have computed, and we found that the spectral accelerations are more at 0 point maximum value we got it. as the period increases, it is coming down. In Ayodhya also, we have to consider number of precautions should be taken in basement of the structure of the temple, and based on this spectral accelerations, you can easily identify at what period is maximum peak ground accelerations has been. Horizontal peak ground acceleration more danger to the structure than the vertical also. Vertical sometimes also it is vertical for dams and other things we have to consider, because dams will have number of parameters we have to consider. Hydrostatic load is acting on the structure, geological formations and everything. We need these periods, structural accelerations also we have to consider nowadays. People in the other countries, they have considered, not simply because of seismic zoning map of India, but they have to consider the spectral accelerations points at each and every part of the country. We need it. Basically, I started doing like this, and the engineers has to consider. See, for example, in 2015, on Nepal, Bihar earthquake occurred, 7.8 magnitude earthquake in 2015. When I published my book on the same day, released out, and on 6 o'clock, I got my publication, first copy. On 10 o'clock, the earthquake occurred. I could not include this map, this event in my book. You see, we established some seismic station accelerometers there in the proximity of the Kathmandu region. We see in this figure we got 4 seconds delay of the accelerographs. You see in the figure in different 4-5 stations accelerometers are there. It has shown what happened immediately. 0 period maximum accelerations will be observed actually, but it is not the same thing. It because the seismic waves which below we have shown you the structural geological structure below that I have shown you the seismic waves which are in the basement of in the basin like this. The earthquake seismic waves have been reflected, multiple reflections have taken place, and because of the serpentates present in that lower portion of this seismic geological portion is showing us the seismic waves reflected inside and coming after 4 seconds it has come out and amplified. So period which is having 4 seconds or 5 seconds, the natural period of the ground is 4 seconds or 5 seconds. The natural period of the structure which is erected in that area will be destroyed. See, for example, we have seen in the damage reports, the pillar which is having destroyed, the oldest pillar in the Nepal region. It was destroyed because of 4 seconds of the natural period of the pillar and natural period of the ground is same. So it was collapsed completely. So this period should not be equal. We have to consider in the design of the structure. This is indicating it is giving us a lesson. See how what is the use in doing all these things? The less number of earthquakes will more dangerous. Say, for example, rarely occurrence in earthquake of magnitude 8. See, for example, in the extreme part of as damage increases, because of the basement force, the seismic acceleration, horizontal free ground accelerations will destroying the basement of the structure, basement of the dam, basement of the any irrigation project or multi-story building, anything. 8 magnitude will create large heavy value and it destroy the structure. If you will consider the value of that acceleration in your design of the structure, then it can sustain. So with that view, we have prepared both things, not only seismic zoning map of India normal way, and you have to consider the frequency domain of the region, natural frequency of the structure, and natural frequency of the structure as well as the ground. The ground is also having its own natural frequency, and structure is also having its own frequency. These should not be equal. How? That's why in this figure we have shown the damage is more For major earthquakes and very small earthquakes, the damage is less. See, different structures. We don't have not all six floors buildings throughout the area, but different structures will be there in any region. We have to consider what are these. For example, white bridges are there in Hyderabad, and another chimneys, very big chimneys, 250 high chimneys are there. It is having its own frequency of 4 seconds. The frequency of the ground as well as the structural natural frequency is same, then it will be collapsed. So wire also 10 second shift is there, the wire bridge also will be collapsed. So bridges also having its own 250, 220 meters high is there, the dam for 0.3 seconds. It will be same as that natural frequency, then the dam will be damaged. If you consider the design, in the design coefficient, your structure will be stable and it cannot be destroyed by any earthquake in the expected magnitude, maximum magnitude of the region. For that purpose, we have prepared the zoning map of India as well as the frequency domain of the region. See, for example, seismic design parameters for dams in general I'm telling, not in specific. In the ranges have been telling. See, for example, seismic zoning factor is a Z factor we have shown in the map. Then within the, say, for example, zone 1, 0.11 to 0.1. For zone 2, 0.11 to 0.16.
Everybody joking, sir.
And 0.2 for zone 4 and 3.6, 0.25 to 0.36 and above zone 5. So depending on zone factor, we have to consider the design of the structures of the dams or any irrigation project. Important factor also is more, this is 1.2, not 0.12, 1.2 to 1.5. This is dependent, this is known as importance factor. For any hospital or any schools or anything, 1.2 to 1.5. Based on that, the structure of the dam or irrigation project, we have to consider importance factor for the dams. I mean, damping ratio 5% to 10% should be considered for the dams and irrigation. Natural period is 0.1 to 1.5 seconds. We have to take care about the while designing the structure in your calculation. This is a spectral acceleration coefficient. For example, seismic zone and their spectral acceleration for 5% damping. This is zone wise, and the response spectrum is zone factor by importance I. Zone factor.
Below half.
Design response spectrum is design response spectrum based on your seismic zoning map and importance factor. So based on your dam importance, dam specific coefficient. So for example, concrete dam 0.1 to 1.2, masonry dam 0.6 to 1.0, earth dam 0.4 to 0.8. Like that, we have to, in general, I'm telling, for your specific structure, we have to design according to your requirement. Thank you very much for your invitation. I entered into the 75th birthday. On this occasion, I have prepared the slides also. Thank you very much, sir. All the best for the engineers. Thank you.
Thank you, sir. So now from participants, if any queries are there, please kindly ask Dr. B. Ramalingeswara garu. Participants, please.
Any doubts or any clarification they want, anybody, I am ready to answer you.
Yes, sir.
Any small, because you are experienced as a cylinder, I'm an experienced seismology. Interaction with the two must be, what is the problems behind during the structural analysis we can understand and we can answer probably from the seismological point of view. We can answer it and make the system smoothly, make the Indian infrastructure earthquake resistant. That is my aim. That's why I have written this book for you to give more clue to the design of your structures, civil structures.
Sir, thank you very much, sir, for having you as the keynote speaker. And your topic is very excellent, sir, and it is very rare area. Most of them may not be having the much knowledge about this one, but you explained in detail about this critical topic, sir, related to the seismic zoning map of India. And you have covered, sir, distribution of earthquakes in India and earthquake risk map for 30 years in India, sir. You have given the good data, sir, and the division of these regions into the zones, creation of spectrums, and comparison of actual and design spectras and seismic design parameters in detail you have given, sir. And though it is a new topic for us, we understood very clearly, sir. So thank you very much for your nice presentation on this difficult topic, sir. So once
My
again,
aim is to give more information to the civil engineers. You are the builders of your nation. So if I will give my seismological input to you, geotechnical, earthquake engineering, and this geological engineering part faults. If, for example, Kaleshwar or some place, eastern part of the fault is very strong material. Western part of the canal is sediment rock. So if you construct any dam there, what will happen? Imbalance of the hydrostatically, the same load will act on both these structures. You know,
yes, sir.
the sedimentary structure load is PSI is same as that of the hard rock. But where there is a low strength material is there, it displaces, the structure will be displaced. Civil engineers has to be considered geological engineering, geological point of view, how the fault will bear the load of the water stagnant there, reservoir, in the reservoir, near dam. The load will be there. So, and another thing is, number of years, after 50 years, for example, after 50 years or 100 years, in spate means flood, flash floods will come and destroy the structures also. And the structure will be deliberate, not because of the earthquake, because of the hydrostatic pressure, the dam will be sustained. You have to design that also in the your design of the structure, dam or any irrigation structure. Apart from the seismic analysis, yeah,
Sir, I have a small doubt, sir.
Huh? Yeah.
Sir, I have a small doubt, sir.
Yes,
Sir,
yes,
you have
sir.
used the accelerators.
Pardon?
You have used accelerators
Pardon?
to measure this. Accelerators you have used, no, sir?
After during my see, I don't understand. What is that, sir?
Sir, to measure these frequencies, to
Ah,
identify the spectrum, accelerators are required.
yeah.
Whether they are Indian made or foreign made, and what is the accuracy and what is the depth up to which they can measure?
Actually, the frequency of every structure is having its own natural frequency,
Yeah.
And the structure below that, you see, when you are constructing any structure on any ground, you have to identify these seismic characteristics of that area. The soil, how much is soil? What is the frequency, natural frequency we can nowadays? Geotechnical investigations will indicate the natural frequency of that area will be known from you. You can understand there are some equations, empirical equations are there. So
Yes,
these
yes.
should not be equal. You have to in your design, if it is equal, if you are assuming that it is equal, then you have to change your design to have a load, live load, dead load, everything you have to change, and coefficients of the stiffness coefficients, everything should be considered and it should be changed. So that the frequency of the your structure will not be equal to the ground. Ground is always same, but your structure is you are designing. The structure is being designed by you. Structure is being constructed by the ceiling rate. So you have to consider what is the nature of natural frequency of the structure. Then only you can design your structure of the natural frequency should not be equal to that. That is the main concept.
Right. Thank you, sir.
Sir,
Thank
small
you.
doubt,
Thank
sir.
you.
Small question. Is
Okay,
it Professor
Professor.
Ramana here? Sir, what is fate of Polavaram and Malan Sagar and also Amaravati? General question I'm asking.
Actually, I have not put my mind completely on the Polavaram as well as some other region because I'm not in there. But generally, they have considered. See, for example, in Polavaram, eastern part. See, for example, I don't know the actual length parameters. I don't have. Eastern part of this structure and western part of the structure, when you are constructing a dam, you should be very careful to know that engineering geology of the area, there should not be any active fault. There should not be any gravitational displacement should not be there. See, for example, in May 1985, one problem had come to this nation, that is Tehri Dam. Tehri Dam was constructed in Bhagirathi River. So that was in the trust zone. 4,000 crores they already spent. They asked what is the design quotient for that. We have given in those days 0.34 I have given, and some other four-man committee is there. I have given it. So in that aspect, what happened? Luckily, that is the whole dam was sitting on the thrust fault zone. Whether you are in the thrust fault zone or normal fault zone or a slightly fault zone, you have to be considering very seriously. Otherwise, the displacement of the structure, the displacement of the pillar will be there. So, any geological formations, displacement may take place because of difference of the geological formation. There should not be displacement. You should consider what type of fault is it. Normal fault, thrust fault, or strike fault. That is why engineering geological aspects we have to consider before designing your structure. More seriously, we have to take that aspect very important, and seismological aspect and the geotechnical aspects. You know, I need not tell, but I'm refreshing before you that all these parameters nowadays, why I'm stressing that not only all these things, frequency domain also is more important. We have been observing in other countries, all they have considered spectrum of the area. What is the spectrum? If you take the X-ray, what is the defect in the lungs or some place, we know. What is the broken bone? You will know after taking the X-ray. Like that, the frequency, if you know, the frequency of the crust, as well as you in your hands, the structural design will be changed, not to equal to the natural frequency of the ground.
Okay, sir. Right. Thank you. Thank you very much, sir.
Thank
So
you.
now I request Dr. K. Sitaram Babu Garu to propose vote of thanks.
Thank you.
Sir, thank you very much, sir. Thank you very much, Speaker of the day, Dr. B. Ramlingeshwar Rao Garu, former Chief Scientist, NGRI.
Printing, sir.
On India new seismic zoning, map of India with different dams and irrigation projects on engineers R.L. Raju 10th Endowment lecture. I thank Chairman of the Institute of the G. Venkat Subbiah Garu.
I must say thanks to my yes,
Dr. D. Rama Garu
who
for
have
having
been
made the event a reality.
yes, sir.
I also thank past chairman, immediate past chairman, Professor Dr. Ramana Naik Garu, also past chairman and council member Dr. A.S.M. Raju Garu, two more members that have while event is happening, P.D. Rao Garu, Dr. P. Garu, Chakri Garu, and V. Srinivas Rao Garu, and made this event a grand success. I thank one and all for having this. Before we wind up, we will stand for test lab.
Thank you, sir.
Thank you.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
जय हे
जय हिंद.
Okay, good night. Happy Dasara, all of you, sir. Good night, happy Dasara, sir. Thank you. ఇవాళ అమ్మవారి పూజ బాగా జరుగుతుంది. సార్ పండుగ ఎప్పుడు ఉంటుంది సార్? లోపల పెట్టేసుకుంటారు కదా ల్యాప్టాప్ అంతా పెట్టేసుకో పీస్ కింద మీరే ఉంది దగ్గర ప్రింట్అవుట్ ఉంటుందా మీరు ఫోన్ పెడతాం
Okay, sir. See you.
పాపం ఆయన ఎందుకు రమ్మండు రోజు ఇంకానే
ఏం చెప్పలే ఆల్రెడీ సీఎం పని ఉంది
సార్ అంతరాం సార్ను రంగారెడ్డి గారు వచ్చి నా జూమ్ వచ్చింది అది ఆఫీస్ ఆఫీస్ వచ్చింది అరే ఇంకా పోలేదు లీవ్